Many of us have witnessed high-speed aircrafts and rockets in motion. When these vehicles move faster than the speed of sound, that is, when they exceed the Mach number 1, shock waves are generated. Shock waves are sharp physical boundaries across which properties like temperature, pressure and density of air that flows over the object undergo a rapid change. These shock waves generate a lot of drag and heating on the aircraft. Therefore, study of shock waves is important for developing better high-speed aircrafts. Now, as we are moving towards hypersonic flight vehicle development, the need to understand the dynamics of shock waves under different conditions is all the more important. Recently, researchers from the Department of Aerospace Engineering at the Indian Institute of Science, Bengaluru, have uncovered new dynamics while conducting an experimental study to observe unsteady oscillations of shock waves over objects.
Now, typically, shock waves, when you have an object moving through air at high speeds, it can be, a bullet, a rocket, an aircraft. These are all things that travel at supersonic or even higher hypersonic speeds. The shock waves move along with the object that is, traversing through air. Now, under certain conditions, the shock waves can also move relative to the object, typically in an unsteady manner. So our study, our investigation was looking into this particular phenomenon of shock waves where they undergo unsteady oscillations over objects.
The researchers experimented with a simple object resembling a right circular cone set on a cylinder. The experiments were performed in the Rodham Narsimha hypersonic wind tunnel, where the object was subject to air flowing at 6 times the speed of sound. That is, Mach number 6. To visualize the flow of shock waves, Schlieren imaging was employed using a laser and a high-speed camera. Opening angle of the cone and ratio of height of the cone to the diameter of the cylinder are 2 parameters that govern this flow. The researchers found that altering any one parameter changed the stability and pulsation time period of the shock wave system.
Through this study, we showed that if you have 2 parameters that control this kind of unsteady phenomena, we had very interesting set of dynamics. So fundamentally, it's a problem that has captured our attention. Now, in terms of practical relevance, although the study is fundamental in nature, it does give the designer of such high-speed aircrafts or other related similar flight vehicles insights into regimes in shock waves that they should avoid in order to stay away from such kind of undesired unsteady motion. So this study definitely gives some insights on that front.
According to the researchers, this class of problems involving shock wave pulsations or oscillations with 2 controlling parameters is reported for the first time. The study has featured in the Journal of Fluid Mechanics published by Cambridge University Press.